Hello, welcome to today's chemistry session. In today's chemistry tutorial, we are not going to cover a particular topic or a concept. Instead, we are going to talk about how to properly storytell while teaching chemistry. The motivation for this recording or the tutorial comes from my several conversations I have with students who have taken chemistry in the past and not now, and sometimes with my conversation with my friends or colleagues. And when I ask them the question, what did you think about chemistry in high school or middle school? Most of the time, the response is, I found chemistry hard. Chemistry was challenging. I didn't really enjoy chemistry. I didn't really like the way the chemistry was introduced for me. Some even argue specifically. They say the periodic table was too overwhelming the way it was introduced. They didn't really like the idea of balancing equation or writing chemical equation and predicting products. While I do relate to them to some extent and understand the fact that a subject can be made difficult or harder based on how it's introduced to the students, what really saddens me is when I hear the fact that chemistry is hard. Because I truly believe chemistry is not a hard subject, it's just made difficult. If taken the right approach, if properly story told, if the topics and the units within chemistry are connected well and organized well and then presented well, I feel like chemistry can be a really engaging subject. On top, if the students see the relevance and application of chemistry around them in their daily life, there's absolutely no reason not to like chemistry or even pursue a career in chemistry. So what I'm going to do in today's session is I'm going to share a method or a technique that I've applied in my high school chemistry teaching in the past few years, and I've found that really important and applicable. So I want to share this first with teachers who are maybe struggling to teach chemistry in an engaging manner, and also to students who are finding hard to get grip of the chemistry subject. Okay, I hope this will be useful. And if you guys have anything on top of this to share or add or comment, please feel free to get in touch with me or write a comment in the comment section. Okay, I'll make sure to take that into account while I prepare my next lecture. So yeah, let's begin. I'm not gonna do a regular PowerPoint presentation for this. What I'm gonna do is basically use a whiteboard and write down stuff the way I do in my regular chemistry classrooms. Okay, so let's get started. Okay, so here's our whiteboard. Let's get started. So what I'm gonna do is I'm gonna basically talk about this in a way I talk to my students in classrooms so that this could be more relatable to you guys. So when I introduce chemistry for the first time, sorry, let me use the pencil. When and use a color, let's use purple. When I introduce chemistry for the first time in the class, the whole goal of the chemistry subject is first to study structure of matter. There are trillions and zillions of matter that surround us, whether it's a building that's near to us, whether it's the trees and plants, whether it's the human beings that are around us, whether it's the food that we eat or the clothes that we wear. Everything is matter and they are made up of something. So our first goal is to see what they are made up of in their fundamental level, right? And then we talk about interaction between particles or the constituents, right? And say, so once we know the matters are made up of certain constituents, atoms or molecules or ions, what's the interaction between them? What's holding these particles together? And finally, we talk about chemical transformation. Okay, we see chemical reactions happening in daily lives. We see things being converted from one form to other, right? Whether it's in the kitchen or whether it's in the automobile that we are using, whether it's in the batteries, we see chemical transformation all the time. So what's happening when these chemical transformations are happening? Or what's driving this chemical transformation? Why are some chemical transformation possible and some aren't? So we talk about all this in this particular section of chemistry. So these are the three basic points that the whole chemistry course focuses on, okay? So So then, talking about connecting dots, I start with matter, and in the fundamental level, all matters are made up of atoms, right? So if you break down any matter that you see yourself surrounded with and get to the fundamental level, you'll see an atom. That's a reality. That's a fact. So now, how does the atom look like? What's the actual structure of atom? Has the atom ever been visualized? Today, yes. We can see roughly in the structure of atom using different types of microscopy. Okay? But this is a very modern finding, right? Over the years, the structure of atoms has been sort of revitalized or improved. So I start from the explanation of Greek philosophers and how the atoms were, and then I talk about the Daltonian concept or the Daltonian idea and Dalton postulates about atom. Then I talk about Thomson plum pudding model, the electronic concept, the idea of electrons mainly. Then I go on to Rutherford alpha ray scattering experiment where it discovered the nucleus, the nuclear model. Then I go to I go to Bohr's model from there. The planetary concept, right? The idea of the energy levels. And then from here I go to the wave model, the most modern and comprehensive model, the Schrödinger wave model. And even we sort of say Schrödinger model, but there are other scientists who are relevant and important in this discovery, right? People like de Broglie or Heisenberg. So I talk about all that while talking about the structure of atom. And along the way, I show them a model of how this scientist thought the atom would look like. And in the Schrödinger's case, I show them the most recent image of an atom or a molecule that's been imaged using different techniques. Okay, from atoms, then the question is, are atoms of all matters that are present in all matters alike? Are the atoms of different matters different? And the answer is, of course, they are different. There are different kind of atoms depending on what element are we talking about. And the question is, how many different kind of atoms are there? Are they arranged in some systematic manner? And of course, the answer is yes, and the answer is the periodic table. I introduce my kids with a very interactive and fun periodic table, right? A periodic table which is not just like filled with information and overwhelming. Maybe it has really nice images for each element and what they constitute, right? So periodic table, from atoms to periodic table, which I call alphabet for the universe. 118 elements arranged in a very systematic manner. I talk about the history of periodic table, all the, what do you call, Dov-Brenner, Newland's law of octaves and all that stuff, Newland's, and then the important one, the Mendeleev concept and the modern periodic table. So here's where I can talk about the whole periodic table. And within the periodic table, then you talk about why does periodic table make the study of elements and atoms and matter simple and easier. It's because they are arranged in a way so that the properties recur. Right? The idea of groups and periods. Within a groups, you have elements with similar properties, with similar electronic configuration. You can even talk about electronic configuration at this point and why electronic configuration matters. It's the electronic configuration, especially the valence electronic configuration, that determines chemical property of elements, right? So that's what I do within periodic table. Talk about the history of periodic table, the importance of periodic table, electronic configuration, the idea of orbitals, right? What does it mean when we say s orbital, p orbital, d orbital? When I talk about the electronic configuration, you can do all that here. Okay, so that covers periodic table. From here, what I do is So let's say from here, let's move on to this. From here, what I do is, let's draw a line here. What I do is I go to the idea of molecules. Okay, even though we say that atoms are the fundamental particle, which they are, but atoms don't exist by themselves in matter. They make molecules or sometimes ions, especially in case of ionic compound or metallic compounds, right? Ions. So what bonds atoms into molecules, right? What keeps the atoms together in a molecule? Or what keeps the ions together in an ionic sample or metallic sample? And there is where the idea of chemical bonding comes from. Let me change the color. I feel like we've used the same color all this time, so let's bring a little bit of fun to this. Okay, so this is where the idea of chemical bonding comes from, right? And I divide the whole idea of chemical bonding, or the chapter of chemical bonding, into two halves. I talk about intramolecular chemical bonding, and I talk about intermolecular chemical bonding, right? In intramolecular, I can talk about, let's say, ionic bonding within the molecule. I think it's a little bit different. I can talk about covalent within the molecule, right? If it's a water molecule, let's say HOH, this covalent bonding are within the molecule. But when we talk about intermolecular, then we talk about London force. For example, the force between hydrogen molecule, this is between molecule. I talk about dipole-dipole interaction. Let's say the interaction between two HCl molecule. You can talk about hydrogen bonds, right? The force of interaction between water molecules. You can even talk about ion-dipole interaction. The force of interaction when a ionic compound dissolve in a solvent, ion-dipole interaction. So the whole idea of chemical bonding, the force of interaction between particles, between atoms, between molecules is covered here. Okay? So once you talk about the types of bonds, then I talk about the theories. How are chemical bonds formed? Of course, these are types of chemical bonds, and these are what's responsible for keeping the atoms intact. But what are the different explanation which describes the process of bond formation? And this is where I talk about hybridization, right? The valence bond theory, the hybridization and valence bond theory, I feel are outdated, but they do provide some picture as to how the bonds are formed. And the most important one, and the most comprehensive, most accepted, and the most real is the molecular orbital theory. This takes into account the wave nature of the orbitals and talks about the constructive and destructive interference between orbitals and the idea of bonding orbital, anti-bonding orbital. So I talk about these three theories here in the process of explaining how the bonds are formed and how the molecules are formed. Okay? So now we have gone from talking about matter to atoms, where we and talking about how the atoms were arranged, how many different kind of atoms are present, and we talked about molecules. Molecules, and how do molecules interact between themselves, and how do atoms within the molecules interact, and we talk about theories of bonding. And from here I talk about the next interesting one, which is, do molecules and molecules react? React. That's a $1 million question. So let's go a little bit to the top. I'm going to start here. This is my third section, so I'm going to just do here third. So this brings us to the idea of the chemical transformation I was talking about right at the start of this session, right at the start of this whiteboard recording. So not all chemical reactions happen. So we see interaction between, let's say, molecule plus molecule, or particle. It could be an element plus element as well. Some happen, some reactions don't happen. Okay? For example, if you talk about the air particles that are around you, Are they constantly reacting with the molecules on your skin? Are they reacting with the protein that is in your hair? And the answer is no. But there are also some reactions that are happening in daily life, right? You talk about the reaction between sodium hydroxide and hydrochloric acid that you see in lab. There is a spontaneous instant reaction. There is a reaction that's going on between air and the liquefied petroleum gas on your kitchen. There is a chemical reaction going on between a organic compound and air in the gasoline chamber in the automobile, right? So what I'm saying is there is chemical transformation happening around us, but when two molecules come in contact, it doesn't necessarily mean that the reaction will happen, right? So at this point, you can first talk about the types of chemical reaction for sure. Since we're talking about chemical transformation, we can talk about types of chemical reaction and talk about all the different combination. We can talk about dissociation, or you can talk about single displacement. I'll just write ST. You can talk about double displacement, and within this you can talk about acid-base. We'll come to acid-base later, okay? So you can introduce the type of chemical reactions. But before, and once you introduce your students with a chemical reaction, the important thing is to let them know, like I said before, is not all the reactions, not all the compounds or elements react when they come in contact, okay? And what determines this? And then we go to this whole field of thermodynamics. Okay? What determines whether or not a chemical reaction will happen? And I talked to them the idea of the energy profile diagram, right? Whether the energy is going downhill or uphill, whether or not there's enough energy to overcome this reaction barrier, right? The idea of breaking the bond and forming the bond. Is it feasible? Is there enough energy available to break the bonds, right? So there are a lot of factors that are responsible to determine whether or not a chemical reaction will happen, okay? So that's thermodynamics. And let's say we know some reactions that happen, okay? They are favorable in energy. They are going downhill in energy. There is free energy available. The bonds are easily breakable. The bonds that are formed are stable. Let's say the reaction happens. We also know now, once the reaction happens, some reactions are fast and some reactions are slow. One fast reaction that I talked about earlier is the reaction between sodium hydroxide and hydrochloric acid. Instantaneous. But there are reactions that are really slow. The conversion of one isotope into other isotope, for example, the conversion of C12 into C13, it's a pretty slow process. Think about the digestion of food in your digestive tract. That takes hours. That's a pretty slow reaction as well. Or you say mediumly fast reaction. So what determines the speed of reaction? This is all chemical kinetics. So I talked about all that in chemical kinetics. So now we know why reaction happens. Now we also know there are fast, medium, and slow reaction. And we can talk about how to change the speed of reaction. We can talk about the role of catalyst. We can talk about how temperature would provide the required activation energy. We can talk about the role of pressure and how it can be used to increase or decrease the rate of chemical reaction, right? We can talk about all this. Also the surface area of the reactants. All this come under chemical kinetics. So we covered thermo, chemical kinetics, and now not all reactions are one directional. There are also reactions which are going both ways, reversible chemical reaction. So this brings us to the whole chapter of chemical equilibrium. Okay, and here we'll talk about Lee-Satelier principle, law of mass action, how to drive a reversible chemical equilibrium into the product side or towards the reactant side, what are different factors that affect the equilibrium, stuff like that, okay? So that's here. So from here, what we can do is, now we talk about the physical chemistry a little bit. Let's go to the other side of the page. I'm going to draw a line here. what I'm going to do is, since we're talking about chemical reaction here, so in this particular point, I'm going to talk about, while most chemical reactions are happening, there is either loss of electron happening or gain of electron happening. And the loss of electron is called oxidation, Leo, and the gain of electron is called reduction, Ger. So most chemical reaction that we see around are oxidation reduction reaction. There is a reagent that is losing electron, and there is a reagent that is gaining electron. Okay, and from there you can go to the whole field of electrochemistry. Pretty interesting one, this one, right? Electrochemistry. You can talk about galvanic cells, the batteries. You can talk about voltaic cell, and how all these batteries and the chemical reaction within these batteries are driven by the fact that some species are losing electron and some species are gaining electron. Okay, so the oxidation reduction process applies to the batteries, and batteries are so important in our daily life. So you can talk about electrochemistry, chemical reaction, types of cells, everything there, Nernst equation and all that. Okay, you can also talk about the acid-base concept here, since we are talking about electron-rich and electron-poor concept species. You can talk about the general idea of Lewis acid and Lewis base here. These two, the idea of chemical reaction, the oxidation reduction, electrochemistry, and acid base, it can be correlated when you are discussing about the chemical reaction, okay, and what's happening when a chemical reaction is happening. So Lewis acid and Lewis base, these are electron donors. These are electron acceptors. These are donors. Okay, so talk about acid base, talk about the modern Lewis acid base concept. You can also talk about Bronsted Lewis acid base concept, and also the initial, the Arrhenius acid base concept. Okay, so that's acid base. So we started from matter, we went to atom, we talked about the structure of atom, different theories, we went to periodic table, then we went to molecule, we talked about the different bondings, and then we talked about the reaction between molecules, we talked about types of chemical reactions, then we talked about what are the different factors that determine whether or not a chemical reaction will happen, the energy concept in thermodynamics, we talked about the speed of chemical reaction, chemical kinetics, and how we can tune that speed. We talked about reversible chemical reaction. We also talked about the idea of electrochemistry, the oxidation reduction within the chemical reaction, and the idea of acid and bases. Okay. So one more thing, when we talk about chemical reaction here, one more thing you can sort of correlate here. Let's go one page down, okay? There's a lot of things I wrote today. I hope this is useful. It's going to be a long lecture today. I usually record 15 minutes, 10 to 15 minutes, which looks like some. Okay, so when you talk about chemical reaction, one thing you can talk about is, so while we studied thermodynamics, chemical kinetics, and chemical equilibrium, we talked about the qualitative aspect, right? We talked about why reaction happened. What's the driving force? Why are some reactions fast and slow? Why are some reactions reversible? How can we take a reversible reaction towards the product or towards the reactant? But we didn't talk about the quantitative part. So when I say quantitative part, I'm talking about in terms of the numbers, the mass, and the number of particles. How are chemical reactions happening? How are molecules reacting in terms of mass and the number of particles? The whole topic of stoichiometry. Okay, the idea moles, number of particles, right? You can say mass. If it's a gas, you can talk about volume. You can also talk about concentration for solution, right? How the dilution, titration, and all that stuff, that comes under stoichiometry. Okay, so that's pretty much how I start my chemistry. First 1 or 2 sessions of chemistry, I talk about how all these topics within chemistry are connected, and then towards the end, I sort of talk about the different branches of chemistry. Once I connect the dots within topic, I talk about inorganic chemistry. Mainly, this relates to the periodic table and all the elements, the metals, non-metals, all that stuff. And then I talk about physical chemistry, which was basically the idea of physical chemistry, the idea of chemical bonding, the force of interaction, the electric potential, the thermodynamics, flow of energy, chemical kinetics, chemical equilibrium. That falls, even electrochemistry, that falls under the physical sciences part, physical chemistry part. And then, of course, the organic chemistry. Well, it's also fundamentally, it's basically what we have covered so far. It also has atoms, it also has molecules. There is also interaction between molecules. There are also chemical reaction. But the fact is, we are focused on limited number of specific elements. I call this CHOPS, carbon, hydrogen, oxygen, in some cases phosphorus, sulfur, and there is nitrogen and halogens. CHOPS plus NX, right? That's organic chemistry. Chemistry that deals with molecules that form life, right? The molecules within our human body, in some cases medicine. That's organic chemistry. So, and I talk about analytical chemistry. This is basically where you talk about, so of course you did the reaction, you made your compounds. How are you going to characterize these compounds? How are you going to confirm that you made this compound? How are you going to measure the properties of your compound, right? All the tools, techniques, the processes that are involved. So basically, characterization techniques like NMR, nuclear magnetic resonance spectroscopy, the infrared spectroscopy, the UV vis spectroscopy, stuff like that, right? You talk about chromatography technique to isolate compounds, right? All that measurements, tools, and techniques that are used in chemistry. So that's how I sort of introduce the 4 different fields, 4 major fields. There's also biochemistry, which can be related to organic. If you want, you can also talk about biochemistry here. Right? There are a few other fields, but let's say 5 different fields. In biochemistry, you talk about all the molecules of life, like amino acids that make proteins, vitamins. You can talk about carbohydrates, right? Sugars, and you can talk about fats and lipids. And what else is there? Amino acids, protein, vitamins, carbohydrate, fats. There should be some more fats and lipids. I'll put them together. There's what else? A nucleic acid, of course, the one that make your DNA and RNA, nucleic acid. So yeah, these are the molecules that you talk under biochemistry. Okay, so yeah, I know it's been a long lecture or long recording. So the whole idea was to share with you guys how I introduce, how I conduct my first couple sessions in chemistry, so that the students, let me go back to this, so that the students sort of get an idea of how the topics within chemistry are related, right? We started from atoms to periodic table, to molecule, to bonding, to chemical reactions, and then to thermodynamics, chemical kinetics. So you can always go back and rewatch the video and see what we did. It's kind of hard to sort of have everything on one page. So I'm pretty sure I might have missed 1 or 2 topics here and there, but what you can do is you can try to sort of think where that topic might sort of fit in to this explanation that we just had. Okay, and once I connect all those topics, I talk about these different fields of chemistry and what these different fields deal with. And what I genuinely believe is starting your chemistry, high school chemistry classes this way will actually provide student with a better idea first how the topics within chemistry are connected, because you have this massive number of topics within chemistry, and the way these topics are designed in the standard curriculum in A levels or IBs or even in +2, a lot of times they are not really well connected, right? So if you provide this connection before you get hardcore into the topic, the students might have a clear picture of where they are while they are while we are explaining a certain concept from a certain topic. They could relate themselves, hey, I'm actually here in this bigger map. I have this map of chemistry. I have these little dots within chemistry. Right now we are here. And this is connected to my earlier topic this way. And this will be connected to my later topic this way. And in terms of bigger categories within chemistry, this falls within this particular area of chemistry. Okay, that's the whole idea. I hope you guys really like this. If you find this useful, try to apply this in your first 1 or 2 sessions, 2 or 3 sessions maybe. If you think there is something I should add on top of this, there is some different perspective I can bring, or some units I can add, or something, on top to make this more engaging and relevant and interesting, please let me know. I'll be more than happy to add that. And you can always provide comment on the comment section. So what I'm going to do here is give you guys the summary snapshot. Okay, this is the writing that I did for whatever we just discussed before. So most of what we talked about is sort of encapsulated in this piece. Okay, so you can sort of go over this. We started all the way from chemistry and the 3 different areas, the 3 central areas that we're going to focus in chemistry. Then we started from matter to atom, to the structure of atom, to periodic table, talking about periodic table. Then we went on to bonding. In bonding, we talked about intramolecular and intermolecular. We talked about the different processes and the concept on bonding. Then I also added this little thing here. So the intermolecular bonding is also going to determine the state of matter, whether something is solid, liquid, or gaseous. And 3 of these states have a different branching on itself, right? So in solid, you can talk about crystal structure and molecular solids. In liquids, you talk about solutions and concentration, dilution and titration stuff. In gases, you can talk about gas laws and properties of gases, okay? So once you go to bonding and molecules, then we talked about chemical reaction between molecules and molecules, the physical sciences, and the physical concept behind chemical reaction, the idea of energy, the idea of chemical rate, and the idea of chemical equilibrium. And we talked about different kind of chemical reactions and how electron transfer was involved in most of chemical reaction, which fall under the category of redox chemistry. We talked about batteries in electrochemistry, which was part of redox chemistry. And we also briefly talked about how chemical reaction can also be expressed and studied quantitatively under this category or the subject or the topic of stoichiometry. Okay, so this covers most of high school chemistry. There is, of course, organic chemistry and analytical chemistry on the side, and biological chemistry or biochemistry on the side. So I've given a little bit about that in the earlier recording, but you can also, I mean, a lot of these concepts are also used in biochemistry and organic chemistry. Okay, so yeah, hope this is useful. So what you can do is you can come up with your cheat sheet or a mapping sheet for chemistry, and also maybe for other subjects that you are teaching. Try to connect dots, try to connect the chapters, try to connect the concepts, and tell a nice story to your students. So yeah, I hope after listening to all that and after applying the idea of storytelling in chemistry, after that applying the idea of connecting dots and units together in chemistry and providing student with a clear map of all these units within chemistry, I hope your student would love chemistry more. I hope your lectures would be more engaging. I hope your session would be more fun. And I hope your students will like chemistry and take chemistry as their career pathway. Yeah, thank you so much, and I'll see you guys soon.